In this video, we're going to be finding the centroid of a composite shape. So for this example, we're going to be looking at the composite shape below. First of all, we need to note the place of the shape on the coordinate axis. This is important as the centroid position is measured relative to these axes. So to make this manageable, we're going to split the shape into two triangles and a rectangle. So each of these individual shapes has a known centroid. So the key idea is that we find the centroid of each of these individual shapes, and then we take a weighted average using their areas. To organise everything, we're going to put this into a table. So here are the centroid formulas that we'll need. So for a rectangle, the centroid is at the centre. For a triangle, the centroid is 1/3 along each direction from the right angle. So we're going to work through each segment in turn. So starting with the rectangle. So the area of the rectangle is the base times by the height. So it has a base spanning from -2 to 4, which is 6, and a height from 0 to 2, which gives us an area of 6 times 2, which is 12. So its centroid is right in the centre. In the x direction, it goes from -2 to 4, so the centre will be at 1. And then we need to take the area multiplied by this x position. So 12 times 1 is 12. And then we do the same for the y direction. So the rectangle goes from 0 to 2, so the middle is at 1. And then we multiply 1 by the area, which gives us AY, which is 12. Next, we move to the top triangle. So the area for the triangle is a half base times height. So the base is 6 wide and the height is 2 high. So the area is a half times 6 times 2, which is 6. So we know that the centroid lies 1/3 of the way from the right angle. So since it's 6 wide, it means that it's going to be 2 from the right angle. So the right angle is located on the x-axis at -2. So if we add 2, that brings us to an x position of 0. So again, we do the area multiplied by this x coordinate for its centroid. So 6 times 0 is 0. And now we can work out the y coordinate for the centroid of this shape. So we know it's 1/3 of the way from the right angle. So the height of this triangle is 2. So we're looking at 2/3 up, but the base of this triangle is starting at a y coordinate of 2. So we have 2 plus 2/3. So rounding to 1 decimal place, this gives us a y coordinate of 2.7. And then we can multiply this by the area to get AY. So 6 times 2 2/3 is 16. Now moving to that right triangle. So again, the area is a half times base times height. So the base for this one is 2, so it spans from 4 to 6. And the height is 2 as it goes from 0 to 2. So a half times 2 times 2 gives an area of 2. And then we use the same centroid rule. So in the x direction, the centroid is 1/3 of 2, which is 2/3. And we know that the right angle is located with a coordinate of 4 in the x direction. So from there, we have to add on the 2/3. So this gives us an x coordinate for the centroid of that right triangle as 4 plus the 2/3, which is 4.7 to 1 decimal place. Again, multiplying by the area, so the 4.7 times by 2 gives us a value of AX of 9.3. Then in the y direction, so the triangle is 2 high, and we have to go 1/3 up from that right angle. So 2 times 1/3 is 0.7 to 1 decimal place. And then we also multiply this by the area. So the 2/3 times by 2 is 1.3 to 1 decimal place. So we need the total area. So the sum of the areas, the 12 plus 6 plus 2 is 20. We need the total for the AX. So 12 plus 0 plus 9.3 is 21.3. And the total for the AY, we have 12 plus 16 plus 1.3 is 29.3. Now we can find the overall centroid coordinate using the formulas. So the x-coordinate is given by the formula x bar equals the sum of the ax's divided by the total area. So this is 21.3 divided by 20, which is 1.1. Similarly for the y, we get that y bar is equal to the sum of ay over the sum of the area, which is equal to 29.3 over 20, which is 1.5. So the centroid of the composite shape is at the point 1.1, 1.5.